Okay, let's do this one. This one's a hard problem. I didn't realize I made it so difficult. So it says compound it monthly. So we know we're using compound interest. So compound interest is A equals P 1 plus R over N to the T power. This is our percentage rate, but we need to divide that by 100. Now be careful, and I messed this up when I originally did this, and it's going to be 0.00876 is our rate. Our original amount, our P is $100. And this 150 is what we want to get to. That's going to be our A. Okay, we want to get $150 in the bank. We want to know how long it's going to take. So this is kind of a backwards problem, and that's why it's extra credit. You're going to have to do a table of values. Now this is a pretty big, the answer is pretty big, and so you don't want to do all these table of values. So I'm going to kind of give you an idea how to do this, okay? So first I'm going to write my equation. A equals, so 150 is what we want to get. 100, 1 plus 0.00876 monthly, that means N equals 12, 12, and 12t. I'm going to simplify what's in the parentheses just to make my life a little easier when I put this in the calculator, and I'm going to go 1 plus 0.00876 divided by 12, and so that's going to give me 1.00073 to the 12t power. What I'm going to do is I'm going to keep replacing that t. Now I'm going to run out of room on here, so I might have to go off here. So we're going to put in for t different values, and we're trying to get out $150. So we're trying to get out A, but we want it to equal 150. So I'm just going to start with 1 to see what that gives me. So 100 parenthesis 1.1233073. 12 times 1 is 12, so I'm going to raise this to the 12th power. That gives me $100.87. That doesn't feel very close, so I'm going to go to 5. I'm going to jump to 5 and see what happens. 100 parenthesis 1.00073 close parentheses. This time it's 12 times 5. Well, 12 times 5 is 60, so I'm going to raise this to the 60th power. That only gives me 104. We did not go up very much. So I'm going to skip up to 20 and see if we need to go above or below 20. So notice how I'm skipping around so that I'm not doing every single one. That's going to take too long. So 100 parenthesis 1.00073 raised to 20 times 12. So that's going to be raised to the 240th power. Well, that only gives me 119.14. I'm going to really jump. I'm going to go up to 50 and see what happens at 50. And then do I need to keep going up or do I need to go down? So now it's going to be 100 parenthesis 1 times 0.0073 raised to 50 times 12. So that's going to be 600 raised to the 600 power. Okay, I got 154.94. So 50 was too high, but not, I mean, we're pretty close. So I'm going to drop back to 45 and see how far, because 154 is over what we wanted. We wanted 150. So I'm going to drop back to 45 and see what happens. Okay? So 100 parenthesis 1.00073 close parenthesis raised to, now I just did it, 12 times 45 is 540 and hit enter. That's 148. Okay, so we need to go up. Let's try 46. Does 46 work? So 100 parenthesis 1.00073. Oh, raised to what power would that? What's 46? 548 plus 12 would be 552 raised to the 552 power. That's 149. We're almost there. 149.6. So if we did 47, what's 47 times 12? I need to know that first. That's 564. So 100, and I'm just playing with my calculator, 1.00073 raised to the 564th power. That gives me 150.92. So my answer is going to be between year 46 and 47. That's a lot of work there. Okay? The next ones aren't as difficult. B says a car, so I'm going to have to erase this because I can't stand it on the middle of my problem. So that's how I did that problem. So you could pause it and go back and look at it. A car once driven off the lot begins to decrease in value. We talked about that. Given the model depreciation of the car. Here's our model. So we're talking about depreciation. So I'm going to write underneath it what each of these stand for. A1 minus R and then my T. So A is 23,000. So that's my initial or starting. R is 0.15. Well, we need to go backwards and get it into a percentage rate. So if we divide it by 100 every time, we're going to times by 100 this time. And so our rate is 15%. Okay, so now we know something. So the first question says, how much was the car originally? Well, we know it's A. So it's just $23,000. Then it says, what does the model predict the value of the car will be after 5 years? Well, this is where we're going to just go y equals, it already has it written out for us, 23,000, 1 plus 0.15, and we're going to raise it to the 5th year. Now, it does say show your work, so make sure you're at least writing this down. Parenthesis 1 plus 0.15, and then raise it to the 5th power. And so it looks like the car, hopefully you saw my mistake. This should be subtraction. And I put addition. So now I need to go back into my calculator and I need to fix that. I'm going to put subtraction. Okay, that makes sense. And the reason I knew I was wrong is because I got $46,000. Well, if this car is depreciating, it's going to be worth less than that. So it's $10,205.22 is how much it's going to worth in 5 years. And then it says, according to the model, what percentage decrease each year? Well, we know our rate of decrease. Here it is. Our rate of decrease is 15%. And you would explain it by saying, I took 0.15, I times it by 100, and because it asked for a percentage, we had to multiply by 100%, and that's how I got 15%.